Hello, good afternoon, everybody. Hope you had a great lunch. We are on our third transformation. We started out with translations, the slide, then we did reflections, and hopefully you reflected upon that yesterday. Okay, and today is rotations. Now, rotations start to mess with people a little bit. The slide, I can see it. The reflection, if you graph the line right, you can do it. Rotations start to mess with people, so we're gonna change our our way of doing these type of problems. If I give you a graph and say rotate it 90, 180, or 270 degrees, you should be able to plot those corner points, redraw the figure, and life is good. We're also doing this counterclockwise. It's always assumed to be counterclockwise. All right. So when we talk about rotations, really not a lot to worry about too much. We have an object, maybe this blue flag, and we want to rotate it around a certain point. Now that certain point is really important. It's called the center of rotation. We can put this wherever we want. Today and in this class, that point will always be the origin, but don't think that that has to be. But the rules that we apply today will work only if it's centered at the origin. So something to notice is this angle right here is called the angle of rotation. So point Q, 40 degrees, lands right here. Cool. The distance is always the same from the origin. But if we go to point R out here and we rotate point R 40 degrees, we're also going to go out, and that angle that I just swept across is also 40 degrees. And the distance from here to here is the same. So it's kind of like, that's what you just got to maintain. All these really important points that kind of create that to there is also 40 degrees. So very good. We have a center of rotation and we have an angle of rotation. Our center will always be the origin, and our angle in this class will be 90, 180, 270. If I say 360, just say you're done, because if you rotate something around the origin 360 degrees, you land where you started. All right. So just to make sure we kind of get a feel, point A, if it starts here at the point 2, 3, what we're looking for is 90 degrees in this direction. So rotating around the origin is just going to go around that circle. So we want to stop when we've created a 90-degree angle. So maybe somewhere in there. All right. And sure enough, there it is. If we take that point and we rotate it 90 degrees, what we're doing is we're making a 90-degree angle right here. Okay. For kicks and giggles, I took this point, 2, 3, and it looks like it became -3, 2. So I'm going to plant a seed right now. If I know the point, what could I do to that x and that y in order to get the coordinates of a point that's been rotated 90 degrees? Just throwing that out. Maybe you see a pattern. Let's look at 180 degrees. Okay, 180 degrees means that we start here, we go around the circle exactly halfway, and we end up right there. And our coordinates at that point, if we can do that real quick, looks like it's -2, -3. Once again, I'm going to plant the seed. If you have a 180 degree about the origin, look at your original point and look at the point that you ended up with. I wonder if you can make a generalization. Just throwing that out. Finally, 270 degrees. A lot of people see this. That's not the 270 that we're looking at. What we're looking at here is this travel. Do 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 do. All right. So let's see. The coordinates at that point are going to be 3, -2. Once again, is there a way I can look at my x and my y and have maybe a little formula that I could do to that x and y to get the coordinates of a point that has been rotated 270 degrees. All right, in a normal class, I'd have you do this maybe 10, 15 times for a 90, for a 180, and 270, and you'd see the pattern, and hopefully you would write that down. You know, things are a little different. I'm just going to plant the seed that that's where I'm going with this. No longer are you going to just have to like see it. I really pushed you on the reflections and the translations just to kind of see it and count it out because I wanted you to work on those spatial skills. We don't do it enough. We have a computer, we type it in, we get the answer. But on the rotation, I've seen enough frustration over the years that maybe this is a good time to show you a cool little trick. All right. Hey, your 4 homework problems all look exactly the same. They give you a shape and they ask you to rotate it either 90 degrees, 180, or 270. Okay? So I'm going to give you a reference sheet on this next slide. This reference sheet is going to allow you to have the rules if we are doing a reflection or if we're doing a rotation. So then I'm going to walk you through 2 examples on how to apply it. All right, this is where you're going to pause the tape, and I need you to write this down. This is a piece of paper, and we're going to add one more section to it called dilations. I want you to have for any test or quiz, the key is that you understand how you're going to use it. How are you going to use it? So right now is an amazing time to pause. And you're back. So right now, hopefully this is written down. Maybe some of you just printed it, you know, hey, I'll just print it. You know, sometimes writing it through and getting that feel, putting your own hands or your own writing is good. So hopefully that happened. What I didn't have you write down were all the pictures. This is going to be in your notes that digitally that I'll post, but sometimes people want to see a picture just to remind themselves, if I go over the x-axis, here's P, here's the x-axis, when I reflect it, boom, okay, and so forth. There's the y-axis, I reflect it, boom. Line y equals x. This is my favorite. You kind of go that distance and then that distance again. All right. The rule, the way this rule works is, here's our original point, 5, -2. What do you do with that x and that y to get our new first number and our new second number? So to get our new first number, I look at the original point, and whatever number that's there, that becomes my first number here. So if that number is -2, that becomes my first value. The second value, I look at the original point and I say, hey, whatever is in the x, I put in the x. And that was a 5, so that's the 5. That's my new point. I graph it, and look at that. It is definitely works. All right, so those are the nice pictures. I also have nice pictures of the rotations. I'm going to really push right here that you don't read that as -x. Read that as the opposite of y. Opposite. All right. Why do I say that? Well, if we have the point 5, -2, and we want to rotate that 90 degrees, what we do to get the first value is we want to tell ourselves, get the opposite of whatever the y value is, the opposite of that. So that is -2. So the opposite of -2 is +2. And then to get the second coordinate, it says go look at what is in the x coordinate, and that is a 5. So that just becomes 5. So I go graph the point 2, 5, I get that, and it does indeed turn out to be a 90 degree. Let's do some examples. All right, so it's really important that you kind of follow this process. If you do it on big ideas, you're not going to, I'm going to move myself up there out of the way. If you do this on big ideas, you don't have the workspace, but I need this work done on the side. All right, so what you're going to do is you're going to have an object. You need to write down the coordinates of each point. So hopefully we feel good about the point A is the point 1, 4. B is the point 1, 2. And C is the point 4, 2. That shouldn't be too tough. All right, this is a 90 degree. So when I use my reference sheet, I'm looking at my 90, and I think it's a good idea to just write the rule down. So it says take any point and do this to the point. Change it to negative, or not negative, opposite of y, x. All right, so the way that's going to happen here is I'm looking for the new point. I want to know where A prime is. I want to rotate A. So what does it say to do? To get this first value right here, it says take the opposite of the y value. So I go to the y value. The y value is 4, and I need the opposite of positive 4, which is negative 4. Okay, to get the second value, it says go get the x coordinate. So I go to the original point, I look at the x coordinate. The x coordinate is a 1. So there's my 1. I've just used the rule to take the original point, do stuff to it to get the new point. Let's graph it and make sure. So if I go negative 4, 1, it's right there. If I want to make sure that's 90 degrees, maybe from the origin, I draw that, and sure enough, look at that, 90 degrees. So that swung it 90 degrees. So that's looking pretty good. I will definitely take that. All right, get rid of that. So ladies and gentlemen, there is our A prime. Okay, let's do the same thing for B. All right, we want to find B prime. To get the first value, it says take the opposite of the original y value. So I go to the y value, it's positive 2. I take the opposite of that, negative 2. And to get the second value, I look at the x and I get positive 1. So negative 2, 1 is right there. That's B prime. The C value. So once again, now you're starting to get it maybe. You're kind of going a little faster. To get that first value, it says the opposite of y. So I go see what is my y value. It's 2. The opposite of positive 2 is negative 2. And then to get the second value, it says go get the x. So I go over here to my point. I look at the x value, and it is 4. So now I graph negative 2, 4, negative 2, 4. I put those together. Ladies and gentlemen, if I rotate that triangle 90 degrees, it lands right there. Now, I'm not that good at this, so I really need to trust these rules. If you're like, well, Mr. Sayers, it's obvious, I can see it. You know, you're blessed. You're lucky. I wish I was like you. Okay, so don't feel free to do that. You may be good to do the homework. Like I said, they're all like this. I'm going to do one more example right here. And in this case, I'm going to do 180 degrees. 180 degrees. So let's look at 180. First, list all the coordinates. This is going to be 1, 4. This is going to be 1, 2. And this is going to be 4, 2. So nothing's changed there. Those are the original points. I'm doing 180, so I'm going to write down my rule. So take any point and change it. How do I change it? The opposite of x and the opposite of y. So I'm capturing this rule. Those should be in your notes or your reference sheet. All right. So in order to do 180 degree, I need to figure this out. I need to find the opposite of the x value. Opposite of the x value. So I go to my original. Here's the x value. I want to write the opposite of that. The second value is negative or opposite of y. The opposite of y. So I go to the y value is 4. So that's negative 4. Wait a minute, Mr. Sayers. This is kind of an easier one. For 180 degrees, it seems like you just take the x and make the opposite of it, and the y, make the opposite of the y. Well, I'm going to go a little faster. So I think that's -1, -2. And I think, well, I better make sure. To get this first value, I take the opposite of the x. The x is 4, so that's -4. And the second value is -y, so I go to the y value, it's +2, so this is -2. Now I go graph my points. -1, -4, that's A prime. -1, -2, that's B prime. And -4, -2, C prime. Draw that. Hey, life is good. I am done. Excellent. All right, and we're going to skip this. Your homework is page 194, 7 through 10. When I say just do that on the side, please list your X, Y, all your points. Put your rule right on top and follow that, and you're going to get it totally right. I'm going to include the answer to number 7 to kind of show you this is what you started with. And you're supposed to do a 90-degree rotation. So you need to graph the original and then plug in those points and then plot those points, connect them, hit enter, get the high five, and move on. I think this is really important that you take the time. I only give you 4 problems. I didn't give you 78 problems and hope you get 10 of them. I gave you 4 hoping you would do all 4. All right. Thank you very much. Have a great day.